Today I'm showing a local StreamKernel benchmark running on my Mac. This is not a cloud cluster and not a scaled-out server setup. It's a single Mac running a synthetic high-throughput pipeline into Kafka, with the run monitored live through Grafana. The point of this demo is simple. Show the raw throughput ceiling of the StreamKernel runtime and Kafka sync path on local hardware. Before starting the benchmark, I'm showing the pre-run state. This gives a clean baseline. Kafka is up, the benchmark topic is absent or clean, and there is no hidden backlog being counted as part of the result. This matters because throughput demos can be misleading if the topic already has data or if the numbers include previous runs. Here, the run starts from a known clean state. The benchmark runner then launches the StreamKernel pipeline using the tuned Mac profile. The runner applies the JVM envelope, pipeline settings, Kafka topic layout, GC logging, metrics capture, and run metadata consistently. For the recording, I'm suppressing the live JVM output. The full logs and metrics still get captured as artifacts, but the screen stays focused on the dashboard instead of showing config paths, JVM flags, or internal run details. What you're seeing in Grafana is the pipeline under sustained load. The source is synthetic, the transform path is intentionally lightweight, and the sink is Kafka. This is designed to measure the core orchestration and producer path without adding AI inference, external HTTP calls, OPA policy checks, or governance overhead. So the claim here is very specific. This is the raw stream kernel Kafka throughput baseline on this Mac. A few things are important about this profile. The pipeline is using a tuned batch size, fixed executor mode, a Mac-specific shadow jar, and a JVM profile selected from the benchmark matrix. The runner also resets the benchmark topic, so the result is measured from a clean start. That makes this repeatable. Same matrix row, same benchmark topic, same runtime envelope, same metrics capture. As the run continues, the key thing to watch is sustained throughput, not just a short spike. A fast system can burst for a few seconds. What matters more is whether it can keep pushing records without drops, DLQ growth, source errors, or sync instability. For this demo, I'm looking for stable processing rate, matching input and output counts, and zero dropped records. This benchmark is intentionally ungoverned. The profile uses permit underscore all security, which means this is not a governance inclusive number. That is by design. StreamKernel has separate profiles for OPA, MTLS, provenance, fail close behavior, and governed enterprise paths. Those runs answer a different question. This run answers, how fast can the raw local pipeline and Kafka sync path go on this Mac? For latency, I'm not using the pipeline percentile panel if the sample count is 0. In this run, the credible latency source is the Kafka sync latency metric shown in Grafana, not the pipeline P50 or P99 panel when there are no captured pipeline samples. That distinction matters. I want the demo to be impressive but also technically clean. The larger point is that StreamKernel is not just moving toy messages through a loop. It is running through the same runtime architecture used by the broader platform. Sources, transforms, sinks, metrics, backpressure controls, and benchmark artifacts. This particular profile strips the workload down so the core engine and Kafka path can be measured without mixing in other costs. At the end of the run, the after script shows the Kafka side proof. It checks that the topic exists, shows the final partition offsets, and confirms the post-run state without printing message samples. That gives visible proof that records were actually written to Kafka, while avoiding exposing payload structure or configuration details during the recording. The clean way to read this demo is, StreamKernel can sustain a very high Kafka write path on a single Mac, with captured metrics, logs, GC data, and metadata behind the scenes. It is not a replacement for the governed benchmark profiles. It is the baseline those governed profiles can be compared against. So the takeaway is this is the Mac throughput ceiling run. It shows the speed of the stream kernel runtime and Kafka sync path under a clean, repeatable benchmark setup. From here, the next comparisons are exactly once delivery, OPA governance, MTLS, AI inference, and policy-controlled pipelines. But this run establishes the foundation. The local engine is fast, stable, and observable.